Now let's talk about writing formulas using oxidation numbers. So an oxidation number is a charge an atom has when it reacts and becomes a cation or an anion. And on your periodic table, we have previously learned that there's a pattern. So on that periodic table, if I can sketch this really quickly, we start off with a +1 on the first family, +2 on the second family, and then the boron family will be +3, the carbon family +4, the nitrogen family will be a -3, the oxygen family -2, the halogen family -1, and your noble gases have a 0. So just a quick little review of that. So looking at these following elements, let's write the oxidation numbers for each of them. So for potassium, its oxidation number is a +1 because it's an alkali metal. So if I have to write the oxidation number, I would write a +1. When I use the symbol for the element to represent the charge of that ion, I would drop the 1 and just put a plus. All right, let's go across. Let's look at calcium. So calcium has an oxidation number of +2. And when I put that charge on the ion, you actually put the 2 first and then the plus. So that's just the chemistry grammar. So if you write the oxidation number, you do have to write the plus sign. So it's not like in math where you drop it. You do have to write the plus sign. Let's go to the third one there, aluminum. So again, aluminum has an oxidation number of +3, but when I'm writing the symbol for the ion, I would write Al3 plus. Second row, so the oxidation number of oxygen is a -2, so I would write on the element a 2 minus. Next we have iodine. It is a halogen, so the oxidation number is a -1. And so again, if it's a 1, you drop it and you would just include the minus sign. And last but not least, we have sulfur there. Sulfur has the oxidation number of -2, and because it's in the oxygen family, I would write 2 minus. So notice these two are in the same family, and so therefore they have the same oxidation number. Now, when we are writing compounds, we're going to be using these oxidation numbers. And so what you do is you take the cation, which is the positive ion, and the anion, which is the negative ion, and you're going to combine them together and have their charges cancel out. So they will be a neutral compound. The cation is always written first. So let's take this first example. So we have sodium and we have chlorine. Our cation is sodium because it has that plus sign. Our chlorine is negative. So we have a +1 and a -1. We can just put those together because a +1 and a -1 will cancel out. And I can write the compound NaCl. So this is table salt. Let's do the next one. So this next one, there's our oxidation numbers on the ions. And this one's a little bit tricky. Notice that the cation, they wrote it right here second, but when you write the compound, remember the cation always comes first. And again, it is a 1-to-1 ratio. A -1 and a positive 1 come together and they cancel out and they are neutral. Let's look at our third example. So we have aluminum ion and then we have our iodide ion. So we have a +1 and a -1. I cannot just stick them together like this because I'd end up with a total charge of a +2. And we want to put them together so that they will be neutral. So I have to ask myself, how many of these iodides do I need to cancel out the +3? If I had 2 more, that would be a -1, a -1, and a -1. That would give me my -3 that would cancel out that +3. And so what you need to do is you need to have 3 of these iodides. So I'm going to write the formula Ali3. Some students, they like to look at it and they ask themselves, how many aluminums do I need? Well, they'll look at the other ion, and the other ion is 1, so 1 aluminum. And then how many iodides do I need? Then they'll look at the oxidation number, and there's a 3 there. So there's kind of a crisscross way to do it. It doesn't always work, but it can be helpful. Let's do the next example. So we have potassium ion and oxide ion. So in this one, we have our anion as a -2, and it's double the charge of our potassium ion. So I'm going to have two potassiums. That will give me a charge of all my potassiums as a +2, which will cancel out the charge of the oxide ion. So I would write this one as K2O, meaning that I have to have two potassiums or two Ks for every one oxygen. Let's do this next one. So I have aluminum and I have sulfide. So you can see that there's a +3 charge and then a -2 charge. So what number does 2 and 3 go into? And the answer is 6. So I'm going to have two aluminum ions. That would give me a charge of +6. And I will have to have three sulfide ions. That will give me a charge of -6. So you'll write the formula for this compound Al3O. Oh, I did that wrong. Al2O3. There you go. So that crisscross would work for this, because you could ask yourself, how many aluminums do I need? And you can look at the charge 2. How many sulfurs do I need? You can look at the charge. There's 3. All right, so practice doing these, putting together the compounds. So stop the video and then we'll come back and give you the answers. Okay, we're back. So for question number 1, we have calcium and we have the oxide ion. They both have the same charge, but just opposite charge. So the same quantity is what I'm trying to say, a +2 and a -2. So I can just stick this together. So CaO. Let's look at the next one. So we have manganese and chloride ion. I'm going to have two chloride ions. So this will be MgCl2. And number 3, we have aluminum and oxygen. And so I'm going to have two aluminums and 3 oxygens, because I have to go up to a +6 and a -6. So I have to have two oxygen, or excuse me, two aluminums and then 3 oxygens to do that. Did you hear oxygen went on a date with potassium? It went okay. False. One oxygen cannot bond with a single potassium. Why? Because potassium has a charge of +1, oxygen has a charge of -2, so you would put this together as a K2O. Let's look at the difference between a monatomic ion and a polyatomic ion. So a monatomic ion is what we have been working with so far. So you just have one element and that element has a charge. So you have an ion. So let's look at a polyatomic ion. A polyatomic ion is a little group that stays together throughout reactions. And so when we write the polyatomic ion, you always want to write it together as a group. And if you need more than one polyatomic ion, you're going to use parentheses to keep it together. You will be having a quiz this unit on the polyatomic ions, so make sure you check the calendar to find out when that quiz is and be prepared for it. So you do need to know the name of the polyatomic ions, the names and the charges. So let's look at combining ions and with cations and the anions with the polyatomic ion and see how those go together. So coming to the first one, we have potassium as a +1, and then this is nitrate, a polyatomic ion. So it's a little group that always reacts together, and overall it has a charge of a -1. So really it acts as one little group, and so you can just put this together with the potassium. So a +1 and a -1, just stick them together. So I will have KNO3. All right, let's look at the next one. So I have calcium ion, and then this is hydroxide ion, and the whole group has a charge of a -1. I can't just stick this one together because it won't cancel out that +2. So I need to have two hydroxides. That will give me a total charge of -2. So you write this with CaOH parentheses and then 2. It's very, very important that you put the parentheses. If you left the parentheses off, you would have this, and that is not correct. That is saying that we have 1 oxygen for every 2 hydrogens and 1 calcium, and that is not correct. We need to have 2 hydroxide groups for every 1 calcium. So again, notice the polyatomic ions are kept together with parentheses. If you have only 1, you do not need parentheses. You just stick it together. So that's a clue for you. Whenever you see that you have 3 elements in the compound, look and see if you have a polyatomic ion. You can look it up if you don't have the polyatomic ions memorized. All right, let's look at the last example. So we have chromium ion, and then there's that nitrate ion again. So I can't just stick these two together because the chromium's a +3 and my nitrate's only a -1. So I'm going to have 3 nitrate groups. That will give me a total charge of a -3. So I will have Cr, NO3, and I'm going to put parentheses around it and then put a 3. So yes, it looks complicated, but this is correct. So I have a 3 inside the parentheses and a 3 outside. And that is saying that I have 3 of this polyatomic ion nitrate that combines with 1 chromium ion. So go ahead and practice this. Stop the video and then we'll come back and give you the answers. Okay, we're back now. So let's look at the first one. So we have strontium ion and hydroxide ion, a +2 and a -1. I'm going to have 2 of this -1. So I will write that SrOH2. Let's look at the next one. We have aluminum ion and sulfate ion. So I have a 3 and a 2. What number does 3 and 2 go into? 6. So I need to bring them both up to a 6. So this is a +6. And I'm going to have 3 of these guys, these sulfates. So altogether that will give me my -6. So I will have Al2. You do not need parentheses for a monatomic ion, so that 2 goes with the aluminum. And then for sulfate, I do need to use parentheses because I have 3 of them. So this is saying that I have 3 sulfate groups, and those parentheses keep it together. Let's do the number 3. So we have sodium ion, which is a +1, and sulfate ion, which is a -1, or excuse me, -2. So my largest number there is a -2, so I need to make sure I have a +2 over here. So I'm going to have 2 sodiums. So Na2SO4. So no parentheses if you just have one of them.